Today I'm not silent. I'll move on to the next, that is powder metallurgy. So in case of powder metallurgy, why it is going to be used as a new modern technology in manufacturing industry. Here, especially with the help of this powder metallurgy, it is defined as a particular form of characterization of engineering powders. It is the production of metallic powders where you are going to see the manufacturing techniques. So conventional pressing and sintering process, alternative pressing and sintering process, and it is a consideration, the design consideration, whatever we are going to see the design consideration that will be taken out with respect to the working. So these are the basic things that has to be considered while discussing any of the powder metallurgy. Before going to the actual topic, first let us understand what is the meaning of a powder metallurgy. A powder metallurgy is a metal processing technique in which the parts are produced from metallic powder. It is an art and a science of producing metal powders with semi-finished and finished objects from individual, mixed, or alloy products, alloy powders without or with addition of non-metallic constituents. So those generally we are going to term it as your powder metallurgy. In case of powder metallurgy, the alloy powders with additives and lubricants are different in mixtures, which is suitable for dye and heating, and it should not affect the green complex and it should not affect the atmospheric uh, impurities. Everything has to be get balanced. Here, the one more thing that has to be considered is the resulting parts, whatever we are going to get, it is having a sufficient strength and density which can be used in the diversified field of application, highly porous parts, precise high performance components, and composite materials which can be produced by your powder metallurgy techniques. So here, especially in case of powder metallurgy, it offers flexibility, the minimization of segregation. Segregation means the segregate different parts has to be segregated easily, so that will be minimized. And here the flexibility can be easily achieved. Here we can obtain different graded microstructures just by varying the physical and mechanical properties of the materials. Here, especially this powder metallurgy offers advantages over ingot metallurgy. So that means the casting was standard casting, whatever we are going to do, you are going to get a good advantages like in terms of quality, you are going to get a good quality, the precision, the accuracy of manufacturing cost. The next is cost of production, the productivity. So productivity means input by output. Whatever the input you are going to get, sorry, not input by it's output by input. Whatever the output you are going to get with respect to the input. So the accuracy, productivity should be there, and also as well as it is having the ability to conserve critical raw materials with high level of material utilization. Some raw materials it cannot be easily available. For those raw materials, it has to be considered and it has to be utilized with respect to the working conditions. So those are the things that has to be considered while considering your powder metallurgy. Nowadays, especially in case of this powder metallurgy, it is a sequence that the powder first are compressed or it is pressed and then it is taken into desired shape and finally it is heated. Heated means it is sintering to bond a particle with hardness and rigid mass. So this is the process. In case of powder metallurgy, it is having a vast history. So with that history, nowadays if you go to consider different examples with respect to powder metallurgy, especially in long days back itself, this portal metallurgy has been used. One of the easy earliest example of portal metallurgy technique which we are going to practice is reduction of iron ore with a charcoal to produce sponge iron powders. So that is whatever the cast iron that we are going to get iron ore. So if we're going to mix it with charcoal, we are going to get sponge iron powders. So that sponge iron powders are subsequently you formed using shapes by forging. A best and foremost example which we can easily understand about what's the meaning of this photo technology is, I think most of you had heard the name Ashoka Pillar of Delhi. The two in older era, it is a best example of this powder metallurgy technique. In case of this manufacturing technique, it becomes an early 19th century when especially the tungsten powder was produced and it strengthened to use in electrical lamp filaments, especially the lamp filaments, whatever we are going to see, the bulb filaments. There you are going to see the tungsten filament. So this tungsten filament, whatever we are going to observe, so that tungsten filament is generally used in considering the manufacturing of the present day technology. Wait a minute, I'll just carbide tool was another important milestone in the growth of because in case of the production, in case of this tungsten carbide tool, it gives the hardness to the material. So whatever the material that we are going to use for manufacturing, it produces the hardness. So that hardness will provide a maximum amount of strength while doing the manufacturing process. That manufacturing process is the machining process. If you are going to use your standard high speed steel, so what happens continuously if we are using, it may lead to the failure of the tool. So that's why what they are going to do is they are going to use the considerations of the manufacturing techniques. So this manufacturing techniques, whatever we are going to use, so that will be considered regarding the applications, whatever applications that we require. So next one more thing. Generally, the porous bearings which are used nowadays, it is also going to manufacture with the help of this technique itself, because this plays an important thing for utilizing or the manufacturing of this powder metallurgy. Well, subsequently, your ferrous and non-ferrous parts, composites, as well as strengthened alloys, which can be used. Apart from finished products, generally this powder metallurgy is also employed in number of useful applications in modern technology. Examples which we are going to consider are catalysts in chemical industries and in food industries, whatever we are going to see. The next is with respect to the working conditions, whatever we are going to see. So, okay, there is some issue in connectivity. So again, I'll come back to the initial thing. So regarding the powder metallurgy, it is a good innovation which takes place with respect to the material synthesis, processing, and finishing with respect to the last 2 decades. It plays a good scope for the working of this powder metallurgy. The techniques which not only become commercial advancement applications in like your aerospace industry, nuclear industry, defense components, especially in 20th century, where in development of good and advanced material processing techniques like automation, mechanical alloying, rapid solidification process, of powdering, cold isostatic pressing, hot isostatic pressing for component fabrications. Those are all is going to become across, especially in last decades. So that's why regarding the applications they are going to consider nowadays. I mean, most of the components, whatever we are going to see, that is going to be manufactured with the help of this. Your sorry, with the help of this photometallurgy technique. Especially this is used to manufacture finished or semi-finished products like bars and sheets, that is the metallic bars or metallic sheets, whatever we are going to see. Nowadays, I think you had seen the roof sheetings. It is also manufactured with the help of this powder metallurgy technology. So, in case of powder metallurgy, it has established a superiority by taking a route of production, producing several industrial components like porous bearings, filters, carbide tools, etc. can be easily understood. The next is, in case of this powder metallurgy, there is a standard of development. Initially in 3000 BC, a sponge iron, which is originated in India and Egypt, and in 1200 AD, the platinum alloy, especially in South America. In 1781, your arsenic alloy, platinum arsenic alloy, it is in France and Germany. In 1790, platinum arsenic chemical vessels, what the vessels which are manufactured with the help of this platinum arsenic is going to be originated in France. In platinum ignotes, that is also in France in 1822. High temperature sintering of platinum powders in Russia, in originated in Russia in the year 1836. In England, the method of producing compact platinum from sponges in 1839. In Europe, sintering of different metals and alloy powders in 1830. Next, in US, the patent of bearing materials in 1870. In especially in filaments of incandescent lamp in US in between 1878 to 1900. In porous metal and materials, same as in US. Cemented carpets in Germany. Next, that is in the year 1915 to 1930s. In 1920s, self-lubricating bearings. 1940s, iron powder. The next is in 1950s and 60s, wrought iron. Those are all converted into powder metallurgy, depression strengthened forgings, mechanical alloying, oxidizing. So those are all is going to be manufactured in 1970s in hot isostatic pressing. Your powder metallurgy tools, those are all originated in US. And finally, in 1980s and 1990s, your metal matrix composites, spray forming, nanoscale powders, one compositions, those are all is going to be manufactured, especially, and these are the history. With respect to this history only, your powder metallurgy is going to be considered. The next is why powder metallurgy is going to be considered as an important thing nowadays. As you can see, powder metallurgy parts can mass produce to net shape or near net shape, which in turn eliminating or reducing the need for subsequent machining. In case of powder metallurgy process, which were very little, about 97% of our starting powders are converted into products. Just imagine the 3%, the 3% is less. Still, if you go for advanced processing techniques and the powder techniques means, then we can go up to 98 to 99 percentage of good material usage, and it can be easily converted to the products. Next, the powder metallurgy parts can be made with a specified level of porosity, which produces porous metal parts like filters, oil impregnant bearings, and gears. So, for manufacturing different types of filters, oil impregnated bearings and gears. To manufacture these parts, generally we are going to consider the working considerations of your different materials. The two porous materials can be easily manufactured. Certain metals which can difficult to fabricate by other methods, which can be shaped out with the help of this powder metallurgy, like tungsten filament for incandescent lamps, bulbs which are made out of powder metallurgy. Those are all is going to be manufactured. The next thing is, in case of certain alloy combinations. Next, in case of certain alloys, which can be manufactured combinations like ceramides, which are made out of other ways, your powder metallurgy compares favorable to most casting process in dimensional control. The powder metallurgy production methods can be automated for economical production. So these are the different types why the powder metallurgy is going to be important. In case of steps in powder metallurgy, it is powder production, compacting, sintering, and secondary operations. In case of powder production, starts with the raw material powder. Powders can be of pure elements, pre-alloyed powders. The next is methods of making powders. That is what the first one is automation, which produces powders of both ferrous and non-ferrous powders like stainless steel, superalloy, titanium alloy powders. Those are all is going to be manufactured. Next is reduction of compound. That is production of iron, carbon, tungsten, molybdenum, electrolysis for making of copper, iron, silver powders. Next, powder along with additives are mixed using mixers, and lubricants are added prior to the mixings to facilitate easy ejection of compounds, compact to the minimize of wear tools. The next, metallic Stearates, graphites, etc. are going to be used. The next is powder characterizations like size, flow, density, compressibility test. This are all is going to be considered while manufacturing any of the steps in the powder metallurgy. The next is compaction. Compaction is performed using dies, which is going to be machined to the close tolerances. These dies are made of cemented carbides, dyed or die steel or tool steel, which are pressed using hydraulic or mechanical presses. The basic purpose of compaction is to obtain a green compact. The green compact is taken from the sintering process. The next is with respect to hot extrusion, hot pressing, isostatic pressing. These are all the things that are going to be considered, especially in case of compaction. The next is in case of sintering. It is a green compact which is carried out in a furnace under a controlled atmosphere. In case of sintering, it is carried out at temperatures about 70 percentage of absolute melting point, and then the bonding occurs between the diffusions of the material, and finally integrity with the help of the compactness. So the sintering, which also serves the consolidate mechanically bonded powders. This discrimination enables the sintering resulting in disinfectant parts, the densification of the parts which enables the significant improvement of physical and mechanical properties can be easily obtained. Sintering can be varied out in variety of furnaces. If you're going to take an example, a mesh built furnaces are most commonly used for manufacturing your sintering type powder metallurgy, wherein it can be go up to 1200 degrees centigrade. So the next one more example is walking beam and pusher type furnaces, which can be used for still high temperature manufacturing techniques. The next is batch type furnaces, which include bell type or box type furnaces. Sintering is normally done under a protective atmosphere. Generally, most commonly used atmosphere includes endothermic and dissociated ammonia. Here, the positive atmosphere or generally nitrogen is used widely used as a the closed atmosphere technique because of the lower loss. The next is in case of sintering, the one more consideration has to be taken note, that is the secondary operation techniques. So here, especially in case of the secondary operations, in this operation includes repressing, grinding, plating, which can be done. They are used to ensure close dimensional tolerances, good finish, increased density, and corrosion resistance can be easily obtained. The next, in case of the secondary operations, so these are the two block diagrams. With the help of this block diagram, you can easily understand the working of the powder metallurgy secondary operation. The first is raw material. In case of raw material, it is elemental metal or alloy powders, additives, graphite or lubricants. Next, it is going to be mixed out. Once it is going to be mixed out, the forming operations like hot compaction and cold compaction. In case of hot compaction, we are going to do the process of isostatic extrusion, die compacting, spraying, pressureless sintering. Next, in case of cold compaction, die compacting, isostatic rolling, injection molding, slip casting, slurry casting. In case of cold compaction, we require the sintering because it has to be done in a closed environment. So that's why an atmospheric like hydrogen, nitrogen vacuum is going to be considered. The next is, so these are the process of sintering. In case of your hot compaction, there will not be any requirement of the sintering process. The next is operation optional operations. Optional operations like manufacturing steps like repressing, coiling, sizing, recentering, forging, re-rolling, metal illustration, oil impregment. So these are all the things that is going to be done with respect to the optional manufacturing steps. So this optional manufacturing step is for giving the hardness to the material. So that's why there is going to require this thing. The next is finished products like operational finishing steps like machining, heat treatment, steam treatment, plastic impregnement, plating, tumbling, nitriding, short peening. So these are all the things that are going to be done, especially for optional finishing steps. The next is finished product. So finally, when all these component is going to be done, or this process is going to be done, then the material which we are going to get, that is obtained with the help of this finished product with the help of powder metallurgy technology. The next is, this is one type of block diagram. The one more block diagram which you are going to see, that is on the right hand side. Both explains the same thing, but here there is a different stages. In case of the right hand side, it is a metal powder wherein it is going to be blended with lubricants and additives, and finally it is going to be made into loose powder. So in case of loose powder, it is going to be sintered. As I said, in cold compaction, I think you are able to see the same, but the arrangement is different. It is of die compaction, cold isostatic, different other methods like rolling, extrusion, explosive, compaction. These are always going to be considered. Whereas in case of hot consolidation or hot compaction, we are going to see hot pressing, hot isostatic pressing, extrusion, pseudo isostatic. These are all is going to be done. So here, I think you're able to see, especially in case of loose powder and cold compaction, as it is explained in the earlier, the sintering process is going to be done. Once the sintering process is going to be done, then it will go for hot forging, and finally this hot forging is going to be transferred to the secondary treatments. Once the secondary treatment has been done, finally the sintering process and the hot forging and hot consolidation is going to be obtained, and finally the final part is going to be obtained. So these are the process How a powder or a metal powder is converted into a powder metallurgical part. Advantages and limitations. Its efficient material utilization enables close dimensional tolerances. Products are having good surface finish, manufacture complex shapes which can be easily possible. And regarding the facility manufactures the complex shapes which can be impractical with other metalworking process, it is difficult to moderate high volume component. Components can be produced at reduced cost. Components of hard materials which are difficult to machine can be easily manufactured. It is possible to produce components energy efficient, environmental friendly, and here regarding it is suitable for moderate and high volume powders of uniform chemical compositions. It can be reflected in finished part. Wide variety of materials, refractory materials, parts with controlled porosity can be made. High cost of powder materials and toolings can be manufactured. High cost of powder material and tooling, less strong parts, less well-known process. Those are all is going to be considered. So at present for today, I'll just stop at this point. Just wait a minute. I'll just call you. So totally 18 of you are present. Tilak Candy,
ಸರ್
ಎಷ್ಟೊತ್ತಿಗಪ್ಪ ಕ್ಲಾಸು? ಎಷ್ಟೊತ್ತಿಗೆ ಕೂತ್ಕೋತಿದ್ಯಾ?
ಸರ್ ನೋಡಿರ್ಲಿಲ್ಲ ಸರ್, ಈಗ ನೋಡ್ದೆ.
ಅದಕ್ಕೆ ನಾನು ಅದ್ರಾಗ ಅಬ್ಸೆಂಟ್ ಹಾಕಂಡೆ.
ನೋಡ್ಲಿಲ್ಲ ಸರ್, ನಾನು
ಅಲ್ವಾ
ಈಗ ನೋಡ್ದೆ
ಬೆಸ್ಟ್
ಸರ್.
ಅಲ್ವಾ? ಕ್ಲಾಸ್ ಇರೋದ್ ದಿನ 10 ಗಂಟೆಗೆ ತಾನೆ?
ಹಾ ಸರ್.
ಹ್ಮ್ ನಿಮ್ ಇಷ್ಟ ಕಣ್ರಪ್ಪ. ನಾವು ನಮ್ಗೇನೋ ಬೇಜಾರು ಅನ್ನಂಗೆ ಮಾಡ್ತೀವಿ ಅನ್ನಂಗೆ ಮಾಡ್ತೀರಾ. ನೀನೊಬ್ಬ ಅವ್ನ್ ಶಶಿನೂ ಅಷ್ಟೇ. ಶಶಿ ಕೂತಿದ್ದ ಮತ್ತೆ ಡಿಸ್ಕನೆಕ್ಟ್ ಆದ ಮತ್ತೆ ಈಗ ಕೂತಿದ್ದಾನೆ ಅಲ್ಲನಾ?
ಇಲ್ಲ ಸರ್.
ಕೂತಿದ್ಯಾ?
ಫಸ್ಟ್ ಇಂದ ಕೂತಿದ್ದೆ.
ಸರಿ ಸರಿ. ಯಾರು? ರವೀಂದ್ರ ರೆಡ್ಡಿ ಅವ್ನು ಲೇಟ್ ಆಗಿ ಕನೆಕ್ಟ್ ಆಗಿದ್ದಾನೆ. ಹಲೋ ರವೀಂದ್ರ. ಏನೋಪ್ಪ ನಿಮ್ ಇಷ್ಟ. ನಾವು ಏನು ಹೇಳಕ್ಕಾಗಲ್ಲ. ಏನಾರ ಹೇಳಿದ್ರೆ ನಿಮ್ಗೆ ಅನ್ಸುತ್ತೆ ಏನಪ್ಪಾ ಸರ್ ಈ ತರ ಮಾತಾಡ್ತಾರಲ್ಲ ಅಂತ. ಏನೋ ನಮ್ಮ ಇಷ್ಟಕ್ಕೆ ನಾವು ಕ್ಲಾಸ್ ಮಾಡ್ತಿದೀವಿ ಅಂದಂಗೆ ಕೂತ್ಕತ್ತೀರಾ ಎಲ್ರೂ ಅಲ್ವಾ? ಮಾತಾಡ್ರೋ, ನಿಮ್ಗಳನ್ನೇ ಕಂಡ್ರೋ ಮಾತಾಡಿಸ್ತಾ